this generic form. That format of a quadratic is what we call standard form of the equation. It's what you guys have seen from time to time again when you factored, when you solved equations, when you've done all that stuff. This is the generic form of a quadratic. And when we go to graph these things, there are bits of information laid within this formula to allow us to graph things by hand quickly. One of the things that we do is, well, first of all, quadratics always look like this. Some shape or another, it's a parabola. The parabola is either up like a cup, or it's going to be down like a frown. It's either going to be up like a cup or down like a frown. And there's one very easy way to distinguish between the two. The way that you can tell whether or not it's going to be up like a cup or down like a frown is because of the value of A. If A is positive, it's always going to be up like a cup. If A is negative, it'll always be down like a frown. And we'll get into more parts of this here in a second.
Is it, you can only tell by A, or can you tell by A?
Just A. A will always give you direction. Same thing if you think about this. This is just a great question. When you have, what does M tell you? Slope tells you it's going to be up or it's going to be down first, right? The same thing is you can rewrite this as an AX plus B, where this value of A tells you if you're going to be going up to the right or down to the right. Yes, sir.
Is this like the same thing with absolute value?
Very similar. Yep, exactly. That's where it's going next. When we did absolute value, I had the A x minus h plus k, where A told you whether it was pointing up with a v or A was negative, was down with a v. Same basic idea. This idea that we're going to start to see, and we're going to talk about a quadratic form of this h and k here in about 3 minutes. The one thing that happens with all parabolas that you will always see is that parabolas are symmetrical about a vertical axis. Parabolas are all symmetrical about a vertical axis, which means every single point that lies on the parabola is always equidistant to that vertical, the imaginary vertical line. Okay? Do you remember how to write the equation of a vertical line? Nope. Let's hopefully remember this. It's either going to be, don't lean in your chair, that's not one of the options, but it's either going to be, yes?
Be like x equals a number?
Yeah, it's always x equals a number. Vertical lines are always x equals a number. Okay. So parabolas have what's called an axis of symmetry. Call it an AOS. Axis of symmetry. This axis of symmetry is always found the exact same way. It's going to be x equals the opposite of b over 2a. And when I'm using this b and 2a, those are the coefficients in front of x squared and the coefficient in front of x. Okay? Yes, ma'am?
Are we using that formula for the quadratic formula and not the one we learned last year with like the, not last year, but like I think 2 years ago with like negative something over 2a?
That's the quadratic formula. This is graphing the quadratics.
Oh.
The quadratic formula allows you to find the zeros of the function. It allows you to find where the parabola crosses the x-axis, if you will. That's what quadratic formula is. It finds zeros. It calculates zeros. This is, we're just graphing.
Okay.
So now you have this axis of symmetry, and you have this a value tells you up or down. But the other thing that happens is that every parabola also has what's called a vertex. This vertex always, always, always lies on the axis of symmetry, which means the x-coordinate for the vertex of every parabola is always going to be opposite of b over 2a. The y value then is just when you substitute in that value of x into here. So let me show you. They have a vertex is always at the opposite of b over 2a, comma y, whatever that value is. It's going to be really easy to do when I show you an example with numbers. Second hour, we got through this in like 20 minutes, all the three forms that I wanted to talk about today. It's really easy. Which is good because we're short. Yes, ma'am. I try not to be calculator dependent.
Well, I mean, like,
Oh, the numbers to calculate to figure out the y value? Yes. I'll show you here with an example. The other thing that we look at here is that when you have a parabola, if it's up like a cup, this point here is its vertex. When it's up like a cup, the vertex is what we call a minimum. It's the lowest value of the parabola. As it's working down, it hits that minimum, then it works its way back up. So your vertex, if we go back thinking about this whole A positive or A is negative, if A is positive, the vertex, would it be a maximum or a minimum if it's on the bottom? It's a minimum. Which therefore means if A is negative, you have a maximum. Really straightforward stuff here today. Really straightforward. Does this vaguely ring a bell from before? That's what second hour said too. They kind of flew through this stuff. This it? Nope. Hey, knucklehead, you got another one.
Hey. Let's see if I can.
Hannah. I'm not rehashing old ones. You should start screaming when you hit, then they'll think it.
you do like a good
Did you add the E in after you? Well, it was just like.
I'll get it later. I want to get through this real quick, if you don't mind. I owe it to you.
That
So.
makes sense.
All right. So let's walk through an example of graphing this with what is it called? A quadratic that is in standard form. I've got 6 graphs for you to do today. 2 of each type. It's really easy. So take 2 pieces and who's your best friend in the whole wide world with the hole punch?
Hannah.
Shh. You're so mean. Nice. Hole punch for you. Why did I sense the sarcasm in that? It's working from the back to the front. One thing that I will suggest as we're doing these types of problems, guys, is that when we start these, take a minute, label what we have. Okay? Take a second, label what your A, B's, and C's are. The reason that I want you guys to do that is that after we're done working with quadratics, we're going to switch into conic sections. Conic sections is another it's another quadratic style problem, but not only are we talking about parabolas that are up like a cup or down like a frown, they can go left and right. We can have ellipses, which are parabolas that touch each other to form an ellipse. We can have hyperbolas, which are parabolas that point left and right or up and down together. And we're going to walk through all of those things. Probably in about a month we'll get to it. Okay? So, like I said, the first thing you want to do is label A, B's, and C's. After that, we're going to do the, since A is positive, is this going to be up like a cup or down like a frown? It's up like a cup, so it means it's going to be a minimum. Believe me, you're going to want to take 2 seconds and write that down, because once you start substituting in values, if all of a sudden your parabola's going the wrong way, and you know that it should be going up, you know you've done goofed by pressing the wrong button on your calculator, okay? So it just takes a second it's a visual check to remind yourselves of the direction of these things, all right? Now we do is the axis of symmetry. So it's x equals the opposite of b over 2a. Well, what's the opposite of negative 8? 8. So it's 8 divided by 2 times 2, otherwise known as?
4.
Yeah, so 8 divided by 4, that is 2. So my axis of symmetry can be at x equals 2, which means I can put in a vertical line. Now, when I draw my axis of symmetry, it should be a solid or a dotted line? Be dotted, right, because it's just there for us to visualize. It shouldn't be a solid one because it doesn't necessarily exist. So I have that vertical line at x equals 2. I also know that my vertex is going to have an x coordinate of 2. The reason that I know that is because the minimum point has to lie on that axis of symmetry. It always will. The maximum will always lie on the axis of symmetry. In order to figure out what the y is then, all we do is substitute in. All I'm doing is substituting 2 squared. Or 2, excuse me. So if I do this, I do 2 parentheses 2 squared, close it, minus 8 times 2 plus 6. Da, da, da. Where's my y value? Where's my vertex then? 2 negative 2.
I feel like this is so much easier.
There's my vertex. From here, what I want you guys to do is I'm always going to ask you to plot 2 points. I want you to plot 2 points after the axis of symmetry. The easiest way to do that is just take the next point to the right or the next point to the left. It doesn't really matter. So if I move to the right one of my axis of symmetry, what's my x value? 3. If I move to the right of my axis of symmetry, it'd be 3. If I move to the left, it'd be 1. I'm going to use 3. And I do the same thing. So let's see, 9, 18 minus 24 plus 6 is 0. I just did substitution. That's it. Okay. So at 3, my x value is 0. Which means, what's my x, or excuse me, my x value is 3, my y value is 0, which means at 1, what does it have to be? 0. Because it's what we call a symmetric twin.
So are you always just picking the one over next to the right?
Yeah. Because a lot of times, if you're moving to the right, it's probably it's positive. That's all. Yes, sir.
Does it matter if you move to the left or the right?
It doesn't matter. Because the next point I'm going to choose is going to be 0. Because 0 is the next point over here. Because if I substitute in 0 for all that, I get 6. Lori,
Why do you have to do it?
I always want you guys to pick 2 points, 2 sets of symmetric twins. That's just kind of my rule.
Just to do it?
Yeah.
Okay. What do you substitute in 2 and 3?
This was my x value for my vertex.
Okay.
This gives me my y value. Because when I go to the original equation, I'm putting in x to solve for y.
Oh, right.
I'm just picking numbers. Just like when you first graph lines. You pick -2, -1, 0, 1, and 2. Draw your line. Plug each other. That's all it is.
Wait, because the x value is 2x, and we just have to go 2x from the point, and we should.
No, it's not linear.
Oh.
These aren't slopes. These aren't linear. Somebody asked me that earlier. It's non-linear stuff. So now, everybody understand why I'm going to choose 0? Because it's easy. Because 0 squared is 0. 0 times 2 is 0. 0 minus 0 is 0. 0 plus 6, though, is
6.
which means if 0 is 2 away, 4 is 2 away, and it's also 6. And that's how you do those. That's it. Okay? Now, you have to bear with me. I've got about 12 minutes here, and I need to get through the other 2. Yes,
How
ma'am?
did you get the 601?
It's called a symmetric twin. If 0 is 2 spots from the axis of symmetry of 2, what's 2 more spots to the right of it?
Yeah, no, but how did you?
How did I get 6 for it?
Yeah.
I put 0 in for x.
So is that you're always going to put 0 in for x?
If I'm all the way over here going the other direction, I'm not going to use 0. It just happened to be close. That's all.
What would you use?
Oh.
4. Whatever's close. It's usually just the next two numbers. The axis of symmetry happened to be close to 0. That's why it works clean. That's all. Sometimes it doesn't work as clean. That's it. You got some? I thought you had two. The other format I want to go through real quick is called vertex form.
What form was this?
Standard. And now it's back to looking exactly like we were talking about with the absolute value, with the h's and the k's. Okay? Now, what's nice about this form is that it is ridiculously quick to graph from. There is really not a lot of work involved to this. Because right from here, you know what your vertex is. Your vertex, in this case, is h and k. Your axis of symmetry is x equals h.
Wait, so what was the other form?
Standard form. In vertex form, it's telling your vertex is at h and k. It tells you that your axis of symmetry is, remember, it's always going to be the x-coordinate of the vertex. It says my vertex is h, therefore, axis of symmetry is at h. It's that quick. Now be careful with this one, just like we did with absolute value. If you have an equation y equals negative 2x plus 3 quantity squared minus 4, where's my vertex? Negative 3, 4, very good. Remember, it's always the opposite sign of the h. Since it's x plus 3, that meant it had to be x minus the 3, negative 3.
If you're squaring the parentheses, though, wouldn't it wind up being 9?
No, this is a different, you're thinking of something different. Because you're not squaring the parentheses, this means junk squared. It's x plus 3, x plus 3. If you FOILed that out, added this, distribute that, then you get standard form. This is a version of the standard form that's more user-friendly.
So that's just like to simplify things. Okay.
So my vertex would be at negative 3, negative 4. Would this be up or down? Down. This would be down like a frown, which means, is this a maximum or a minimum? It's a maximum. Very good. Now, the other thing with this, then, knowing that your vertex, and I really don't have as much time as I hope for, as I'm going through this. If I know my vertex is at negative 3 and negative 4, the axis of symmetry has to be at negative 3. What's the other two numbers I'm going to use to simplify to find my symmetric twins? I could use negative 2, and I could use negative 1. And in this case, could I use 0? I can use 0 for this one. It's pretty darn close. Sometimes 0 doesn't work out really well because it might give you a point that falls off the graph completely. We did this second hour, and I wound up with a point down here at negative 55. That's why that dot's there. Okay? So sometimes 0 is great. Sometimes it doesn't work as cleanly as you'd hope. All right? And you graph it the exact same way. You plot the vertex, you know it's going to be pointing downward, you pick some symmetric twins, you plug and chug, you go to the next problem. It's really quick. You look so worried.
Numbers. Where do we even get the number?
What I don't understand here. What are you confused about? H and K or what?
No, I'm just wondering where we got the numbers from, just to put in there in general.
These?
Yeah.
I just made it up.
Oh, okay.
I just picked a problem out of air. Yes, ma'am. All right, H and K is always the opposite of H, or it's the opposite of whatever the number is for H. K is the same. So if it's x plus 3, it's going to be net minus negative 3. If it's x minus 4, then it's just 4. Correct.
So do you not use the h or anything?
Tells you direction.
Or why is it negative 2?
Just means negative 2. That's all. It's just a scalar. is all it is. It's going to tell you, the A value is going to wind up telling you how fat, how skinny something is. That's all. You think about slopes, the bigger the number, the steeper the slope. Same thing with this, the bigger the number, the bigger, greater the absolute value, the tighter the curve is. The smaller the absolute value, the fatter the curve is. I only have time for one more on this, and I got to go to the next one, so you guys got homework here. If you get lost, you can watch the video for the second hour. It's a lot longer.
What do you actually use this? Can't you just find the vertex from the standards?
Yeah, but if you're not given standard form, you'd have to do a lot of work to get it to vertex form. Sometimes you're given vertex form, sometimes you're given standard form, sometimes you're given the next form, which is called intercept form. Intercept form is when you have a factored version of a quadratic, where P and Q are zeros. Is zeros ES or O? Just OS? Sure, there it is. When you have what's called intercept form is when you are given the factored form of a quadratic. If you take x squared plus 3x plus 2, and that means you factor it down to be x plus 1, x plus 2, that means you have zeros at -1, -2. So what this case does is that you are able to graph a quadratic given where it crosses the y-axis. You're getting the zeros of the function. So what happens then is that you get this axis of symmetry. Your axis of symmetry occurs at the midpoint of P and Q. And I'll show you an example real fast of this one too. This is another one that's really simple to work with, but we utilize it a lot when we start talking about trajectories, problems that have the initial velocities going straight up and coming straight back down. All right, we're talking about shooting cannons, shooting arrows, things like that. Golf balls, if you have an initial velocity that has a parabolic curve to it. We know a starting point, we know an ending point, we can find a maximum height rather easily. So here's what it looks like. If we take y equals, just trying to keep them easy, 2, x minus 4, x plus 3. Let me change this to a 6, that way we can keep even numbers for you guys right now. If I have x minus 4, x plus 6, what are my zeros for that? What makes that a 0? 4 and -6. So this means that this parabola crosses the x-axis at 4 and -6.
So
Well,
for this one too, it's like the zeros and the opposite.
yeah. Will this one be up like a cup or down like a frowny thing? The rules for A hold true. The A value rule holds true for all three of these. Okay. Now, I'm going to find the axis of symmetry. So in order to figure that out, we have to find the halfway point between the -6 and 4. So here's what we do. We count.
Oh no.
Oh yeah! 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10 total spots. What's half of 10?
Okay, last 7.5.
I did today. Ready? Come back 5. 1 little, 2 little, 3. You're not helping me. Ready? 1 little, 2 little, 3 little spots, 4 little, 5.
Just stop at 5. Just say 5.
There's my axis of symmetry. My axis of symmetry is that x equals. There you are. Yes, ma'am.
Okay, so 4 and 6 is where it crosses on the x-axis?
Yes, ma'am.
Alright.
For -6.
I mean, that's what I mean.
So now my axis of symmetry is at x equals -1, which means what's the coordinate for the x value of my vertex? How do I find the y value? Math. So you get 2, -1 minus 4, -1 plus 6. Ladies and gentlemen, put that in your calculator. Don't try and do it in your head. Too many of you guys will mess that up. No offense. Negative 50. Hey, that's why it's down there. So where's my vertex? It's at negative 1 and negative 50. It's down there.
So what happens if we just like a vertex that
You shouldn't. I tried to make sure you didn't. Guys, there are the only other thing, I know that I kind of flew through these. By all means, if you got hung up on any of these things, second hour, we did the whole thing. We did a couple extra examples of both of them. Today we got a little short here. Watch second hour's video if you got lost on it. It's really quick, quite simple. The only other style question that I have for you guys to work on tonight is that I gave you guys 2 questions, one that's in vertex form and one that's in this intercept form. And I want to see if you remember how to map to make it look like standard form. Okay? So the homework ones, do you have it open right now? What are they again?
Wait, I don't have that part open.
The homework is actually on the old textbook stuff, like I just said.
20, 22, 28,
20, 22,
28, 29, 34,
36,
41,
41,
44.
44. Now, there are 6 graphs, 2 of each type. Use the graph paper. Bless you. Yeah. Why not? Okay. So again, like I said, when we're working with these problems, what you guys have to go to, give me a second, I'm going to show you where it's at again. Back on the site, we're going to hit old book tonight. We're going to be on old book, and it's on this part right here where it pops out. Show it in a second. Graphing quadratic functions.
It's the assignment right.
It's this assignment right next to it. I accidentally read 354, so it'll be 254.
What does that say?
It's on the website. All right, it's right there. Yeah, that's why I gave you extras. You should have grabbed a spare, 2 of them, I thought, when they were going around. If you didn't grab 2, I got extra up here. But I know I had to kind of fly through it. You got lost and through those things. Make sure you guys watch the other video then, all right?
Can we have this graph?
Like a minute left.
And there's 5.